Hi students, this is AJ sir. Let's study 10th standard ICSE Math, Chapter 25C, Probability Part 2. Exercise 25C, Question 1. A bag contains 3 red balls, 4 blue balls and 1 yellow ball. We want to find the probability of the ball being removed is yellow. First of all, the total number of balls is 8. So the number of elements in the sample space is 8. The probability of getting a yellow ball, as per the formula, will be 1 upon 8 because out of the 8 balls, 1 is yellow. Roman number 2, what is the probability of getting a red ball? Well, out of 8 balls, 3 are red, so it's 3 upon 8. What's the probability of getting a ball which is not yellow? If it's not yellow, then it has to be red or blue. That's totally 7. So 7 upon 8. Roman number 4, probability of neither yellow nor red. Well, that could mean blue. So blue balls are 4 in number. So the probability is 4 upon 8, which is 1 upon 2. Remember to reduce it whenever you can. Next sum. Let me give you the cancellations first, which are easy sums and of the same type. Question 2, 4, 6, 7, 8, 11, 12, 13, 14, 15, 16. If you wish to solve them, you may. Mark the 19th one as IMP. Cancel the 20th one. Cancel 22, 23 is IMP. Cancel 24, 25 is IMP. 27 is IMP. Cancel 29, 30th is IMP. 31st is IMP. Cancel 32, cancel 34, 35. So now let's start with the fifth sum. A and B are friends. Ignoring the leap year, that means the normal year which has 365 days. Find the probability that both the friends will have a different birthdays and the probability of them having the same birthday. There are 365 days. Let's assume that A's birthday is on, let's say, 1st October. Let's assume 1st October. So that means B's birthday should also be on 1st October. Then only we would say they have the same birthday. If it is on any other day, then we would say that their birthdays are on different dates. So out of the 365 days, only one date satisfies the condition, the 1st October. The remaining 364 dates would not satisfy the condition. And that would be true no matter what birth date you choose for A. If you would have chosen A's birth date as 1st January, then out of the 365 days, only one date is valid for B to have the birthday on the same day as A, which is 1st Jan. The remaining 364 days would mean that B's birthday falls on a different day. So the probability of them having different birthdays is 364 upon 365, and the probability of them having the same birthday is a very rare event. It's 1 upon 365. Next, let's do sum number 19. It's an IMP sum. 52 cards. What's the probability of getting a queen of red color? A queen of red color where we have 2 red queens, a diamond queen and a heart queen. So that's 2 upon 52, which is 1 upon 2. What about black face card? Well, we have 6 black face cards, 3 spade and 3 club. So the probability is 3 upon 26. Probability of having a jack or queen of hearts, that's 2 cards. So 2 upon 52 is 1 upon 26. Probability of getting a diamond card, Well, in the suit of diamond there are 13 cards, so 13 upon 52 is 1/4, obviously, because diamond is one of the 4 suits. What is the probability that the card is a diamond or a spade? That will be 26 upon 52, 50% chance, as you can see. Now, the 21st sum. There are 7 cards. 8, 9, 10, Jack, Queen, King, and Ace. All of diamonds. So totally how many cards? 7. Roman number 1. What is the probability of picking up an 8 or a king? So out of the 7 cards, 8 or a king would be 2 cards. So the probability is 2 upon 7. In Roman number 2, it's mentioned if the card is drawn and put aside. So now how many cards are left? 6. Out of that, what is the probability that the card is an ace? Well, we have only one ace in the set. So the probability of that would be 1 upon 6. And what will be the probability of getting a king? It's an impossible event, 0, because the king is already kept aside. That's your B part. Now the 23rd sum, again IMP. There were totally 4 defective pens and mixed with 16 good ones. So totally how many pens are there now? 20. Out of which 4 are defective and 16 are good. One pen is removed randomly. What is the probability that it will be a defective pen? Well, it's definitely going to be 4 upon 20. That is 1 upon 5. 20% chance. Now what if the pen that we removed was defective indeed, and we did not replace it, we kept it aside? So now how many pens are left totally? 19. Now once again, if we remove a pen, what is the chance that it will be defective? So total pens left are 19. That's your new sample space size. And in that, how many defective pens are left? 3. Because one of them we have already kept aside as per the question. So now the probability of getting a defective pen is 3 upon 19, and the probability of not getting a defective pen will be 16 upon 90. Obviously this plus this will be equal to 1. They are complementary events. Next, the 25th question. A circle is drawn inside a rectangle. The dimensions are given, and we have to find the probability that randomly will the dice fall inside the circle or outside the circle. What are the chances? Well, as you can see, the rectangle's area will be 40 into 30, that's 1200 centimeters squared, and the circle's area will be pi r squared, where radius is half of diameter. Diameter was given as 20 centimeters, so radius is 10 centimeters. Don't convert it into decimal, leave it as a fraction, centimeters squared. So let's find the area outside the circle. Area outside the circle is area of the rectangle minus area of the circle, which is, after LCM, comes out to 6200 upon 7 centimeters squared. Do not convert it to decimal place. What's the probability that the dice falls inside the circle? Roman number 1. Well, it would be nothing but the area of the circle upon the total area, which is the area of the rectangle. So that's 2200 upon 7 upon 1200. So the denominators are together here, and you get the answer as 11 upon 42. And what is the probability that the dice falls outside the circle? Well, that will be the outer area upon the total area. So that will be 6200 upon 7 upon 1200. The numerator's denominator goes to the denominator, and we get the answer as 31 upon 42. Or you could have simply done 1 minus 11 upon 42, because these two are complementary events. So their sum will be equal to 1. Next, the 27th sum. 3 coins are tossed together. Okay, so the sample space will have 8 possibilities, because 2 cube is 8. 1, 2, 3, 4, 5, 6, 7, 8 possibilities. tails, tails, heads, tails, heads, tails, tails, heads, heads, tails, 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 heads, tails, tails, head, tail, head, 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 tail, and head, head, head. Roman number 1, what's the probability of getting exactly 2 heads? 3 heads, nope. This one, yes. This one, yes. This one, no, no, yes. No, no. So I got 3 of them having exactly 2 heads. So it's 3 upon 8. That's the probability. Roman number 2 says at least 2 heads. At least minimum 2 heads. That means more than 2 is also allowed. So 3 heads are also okay. So this one is also included. And of course these, none of the others are valid. So now 4 upon 8 is half. Next, Roman number 3, at most 2 heads. At most 2 heads means maximum 2 heads. So 3 heads are not allowed. 2 heads are okay, 1 head is okay, and 0 head is also okay. Because they said at most 2 heads. They didn't say exactly 2 heads. Maximum 2 heads. So is this allowed? Nope. This one, yes. This one, yes. This one, yes. 1 head is allowed. It's not more than 2, right? This one is allowed, yes. Does it have more than 2 heads? No, 0 heads. 0 is still less than 2. This, yes, this, yes, this, yes. So that's 7 upon 8. So Roman number 2 was half, and Roman number 3, 7 upon 8. Roman number 4, all tails. All tails, well, there is only one possibility, so that's 1 upon 8. And finally, at least 1 tail. At least 1 tail. Minimum 1 tail should be there. So 2 tails are okay and 3 tails are also okay. So all these 7 possibilities, the only thing missing here is H, 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 because that has 0 tail, not allowed. So the probability here is 7 upon 8. Next, the 30th sum. So, in Delhi, the work week is of 5 days, Monday to Friday. There were 2 employees. They remained absent for 1 day in the same week. So what's the probability that they were absent on the same day? First of all, the sample space would look like this. Let's assume the first employee was absent on a Monday or a Tuesday or a Wednesday or a Thursday or a Friday. We don't know which. And the second employee could have been absent on a Monday or a Tuesday or a Wednesday or a Thursday or a Friday. So there are various combinations here. Maybe the first employee was absent on a Tuesday and the second on a Wednesday. Maybe the first employee was absent on a Thursday and the second employee also on a Thursday. So there are 25 possibilities. Since there were 5 days of the week, 5 square is 25. So 25 possibilities are there. And yes, we have to list all of them compulsorily. What are the chances that both of them were absent on the same day? Well, out of 25, there are only 5 scenarios in which this condition is valid. So the probability of such a thing happening, which would be a headache for their boss, both of them absent on the same day, who will do the work then? The boss wouldn't like to do any work, right? So probability is 5 upon 25, 1 upon 5 is the answer. But what's the probability, Roman number 2, of them being absent on consecutive days? Well, it could be Monday, Tuesday or Tuesday, Monday. Tuesday, Wednesday or Wednesday, Tuesday. Wednesday, Thursday or Thursday, Wednesday. Thursday, Friday or Friday, Thursday. These are all consecutive days, back-to-back days. We can't say Monday, Friday. That's not possible. We don't call it consecutive, do we? Monday and Friday? No, they are not consecutive. Or Friday, Monday is not consecutive. No. So, which ones are allowed here? Monday, Tuesday, Tuesday, Monday. Then Tuesday, Wednesday, Wednesday, Tuesday. Then Wednesday, Thursday, Thursday, Wednesday. Then Thursday, Friday, Friday, Thursday. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 upon 25 is the answer. And what is the probability that they were absent on different days? Well, if 1 upon 5 is the probability of them being absent on the same day, then just subtract this from 1, because same day and different days are complementary events. If they are not absent on the same day, obviously they are absent on different days, which could be consecutive or non-consecutive. That doesn't matter. So 1 minus 1 upon 5 is 4 upon 5. No need to make a list of all the possibilities here. This method will save time. Now the 31st sum. There are some black balls, we don't know how many, let's assume it to be x. And there were 30 white balls. So totally how many balls are there? X plus 30. If the probability of drawing a black ball is 2/5 the probability of drawing a white ball, find the number of black balls. So number of black balls is x, total number will become 30 plus x. Probability of removing a black ball is x upon 30 plus x. And of white ball it is 30 upon x plus 30. Or 30 plus x. But according to the given condition, the probability of removing a black ball is 2/5 the probability of getting a white ball. So that's your equation. Now don't just cross multiply it. X plus 30 cancelled. Simplify your calculations. Cut 6 into 2, 12. That's the answer. Simple. 38th sum. A box contains a certain number of balls. We don't know how many. We know that the probability of getting A is 1/3. The probability of getting B balls is 1/4. And C balls, there are actually 40 C balls. So how many total balls are there? Well, we know that the probability of removing a C ball will be 1 minus probability of A plus probability of B, because A plus B plus C is 1. Their probabilities will be equal to 1. So if A is 1/3 and B is 1/4, then probability of C after calculations, LCM and all, is 5 upon 12. That's the probability of removing C ball, 5 upon 12. But the formula of removing a probability is number of events, that is C, number of C balls, upon total number, that is total number of balls. Now number of C balls is given as 40. So now I can cross multiply and get the total number of balls, which comes up to be 96. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.